So the first topic tonight is web application security. Last night we looked at web services, I believe, and web services security. They are related because they're web. Both are web, so some relationship there. The objectives for tonight describe the technologies used to implement web applications. We weren't satisfied with just having web pages. We had to make them fancy, and when we made them fancy, we made them more attackable. Anytime that you add a bunch of stuff to a machine, stuff being a good technical term, you're going to increase the attack surface. When you increase the attack surface, you have a better chance of being compromised. So, and then understand typical attacks that can be made against web applications, and the lab actually has sort of has a couple of those where you install a piece of intentionally vulnerable software and do a couple of the attacks that they talk about. If you want one of your own, it's OWASP, I think. WebGoat's what it used to be called, is an Adobe web server that is intentionally vulnerable, and you can try out different attacks. They have instructions on how to do them if you want to see how those things go. Identify secure web coding concepts for web applications. Harden web browser software and usage. And a lot of what the attacks are today is not on the websites themselves. Well, it is on the website because they corrupt the website, and then that attacks the browser and attacks the weaknesses in the browser. So the web application, the basic web page is static HTML. It didn't provide enough motion and action and options, so we added APIs, application program interfaces, to extend those to extend the functionality of the web page. When we did that, we added scripting and several different kinds of scripting, some of which are more vulnerable than others, some of which some browsers and some operating systems won't support anymore. So anytime that you add scripting, you're adding some vulnerabilities, and the script and the parser are going to have some vulnerabilities. The CGI Common Gateway Interface it allows the servers to process data supplied by the client. I put in a chat board one time, and it used the CGI script with, I think, probably with Perl. You use CGI. In its process, the browser requests the HTML page containing a form from the HTTP server. The user completes the form, submits it, and then the form uses a POST or a GET method to transfer the data to by the user to the server. So when we transfer it to the server calls an executable program or a script, and then the program processes the input and gives an output to the user, which passes it back to the web server to the user. One of the kind of interesting things, and I think they fixed it on most of the chats, is that you used to be able to upload scripts into the chat itself, and when you clicked on that particular answer, reply, or whatever else, it would then run the script, and that's part of the way the things got infected. Active Service Pages, ASP, is a Microsoft thing, and it came with, it was in NT4, I believe, or IIS4. And it offered functionality something like CGI. Again, the browser requests a page with an ASP extension. The server recognizes that page because of the extension and sends the page to an ASP.dll for processing, DLL, dynamic link library. The script's then executed in the content, the dynamic content is incorporated into the page. What these scripts allow to happen is for the pages to change, and you can actually have different pages be produced under different circumstances. And the ASP.NET is part of the Microsoft.NET infrastructure. PHP, PHP Hypertext Preprocessor. PHP is a scripting language that can be used for a number of things. If anybody's ever used Moodle, it actually is one big set of scripts, produces web pages. It's a learning management system, and it uses PHP and MySQL to form all of its pages. So it takes all of its information really out of using PHP and MySQL out of the databases. And then Java, I'm beginning to think that Java must have an update about every 10 or 15 hours.
More like every 3 hours.
Yeah, I know. It just keeps, every time I turn the computer on, I've got a Java update, and then they want to trick you into installing other stuff too. That's what I hate about that one, because you got to pay attention to it. And I didn't do it the other day. I got in a hurry, and then I installed some Yahoo something or another. It's Sun Microsystems. It's several different implementations. I think that a number of, well, I know that a number of, some of the browsers don't support Java anymore. The advantage of Java over ActiveX, ActiveX being Microsoft's rendition of giving us motion action in the web page itself, is that Java does run in a sandbox, and ActiveX actually has control of everything. So ActiveX becomes a little bit more threatening or destructive than Java does. The Java applets run on the client side, so they're getting it, offloading it to as much as possible to the client. Databases, structured query language, SQL, MySQL, Microsoft has an SQL server. These things use relational databases, meaning that we're going to have a primary key of these things. So there's a schema involved in them. Relational database management system for these things. Then we have the NoSQL, which is an unstructured data, but you can have structured data within it. The unstructured data here, no, or a flexible schema, has documents, key value stores. It does not have columnar database. It can have columnar databases, but that's not a requirement. And it has graph stores. The NoSQL can meet peak performance demands and analyze big data. Big data being unstructured data, because it comes in so fast and gets affected to the point that you really can't put it in a structured format. XML, extensible markup language, is one that's used with a page that it goes and gets the information to fill the blanks in on a page. So it works with the pages itself. It describes the information so that it can be transferred between different applications. Web services, SOAP, Simple Object Access Protocol, is another one of these methods is a means for the web servers to exchange information in XML format. And then web content management systems. Those are things like WordPress, Joomla, Drupal. And I know probably you heard, but it was a week and a half, 2 weeks ago, maybe 3 weeks ago, Joomla had a problem. A whole bunch of pages got infected because they hadn't kept up to date with the latest version of it. So when you do have these things, it's not like the content management systems. It's not like you can just put it on, leave it, and forget it, and then you don't have to do anything. They update them. These are a method to build web pages from templates, and so you can get a web page up and running pretty quickly about that, like that. Web application exploits. And in an exploit, we're going to attack a vulnerability, and a vulnerability is going to be a weakness. And a lot of times this is a design flaw. Web applications, like any other application, we have humans writing them, and when we do that, we're going to have errors along the way. So any of those things are going to cause the vulnerabilities, and then they discover the vulnerability. You have to find an exploit in order to do that. Kevin, with Metasploit actually has the exploits in it. You use the ones that are available for the operating systems that they're available for. There are still a number of them. I think they're becoming fewer as the Windows and as we, the users, and the trainers become a little bit more aware of what's going on and make users aware of what's going on. Special circumstances in its web application exploits, and one of those is that they have to get the information out so quickly, make changes so quickly that you're really not always able to do the checking that you should. Kits, Impact, Neosploit, and you install these on a site. Interesting thing, let me drag this in here a second if I could. This is from the AVG Threat Labs, a Neosploit exploit kit. Neosploit went away, it came back, and then I think that the exploit kit's not being downloaded anymore. But the rank this week, and I don't know which week this was because this just showed up in a Google search. It was 1952. The websites affected 542 users. Not a huge number, but it's still 100 users that have been affected by this thing. And the operating system is all Windows. And the exploit summary of Neosploit Exploit Kit is a web application that takes advantage of vulnerabilities in ActiveX and Adobe Reader in order to hack computers via malicious scripts planted on compromised websites, or malicious files remotely attack your computer while surfing the website with browser exploits, or when opening malicious file received in an email. It may result in unwanted software, see also Trojan horse, being downloaded to your computer. These type of threats invade the PC with the help of infected links, websites, and email attachments, and we're always back to the email attachments. And the key there is don't train your users to not click on attachments. And sometimes even attachments, we say don't click on anything from somebody you don't know. Sometimes you may get one that really appears like it comes from somebody you do know, because you can make that from line from Larry Coldiron show up in a lot of different places for a lot of different users, and you can make the email appear that it has come from somebody else. But anyhow, the exploits here are installed on a legitimate website, like the summary said. They take advantage of the type squatting, which we talked about earlier, which is people typing in typos, typing in URIs, I'll try to use the right terminology, email links, things like that, that you click on something and it gets, and it then gets you. Zero-day attacks are vulnerabilities that nobody knows about yet. When they happen, the developer is typically going to have to scramble in order to create a fix for it. But zero-day is something that's been around. And if the hackers are really proficient, they're probably not going to tell you about it. They're just going to keep using it until somebody else discovers it. And that's happened in a couple of instances. That happened with the what OpenSSL had a flaw, and that flaw had been around for years. Then that the people that knew about it were not the white hat kind of variety, so it was there. Input validation. In this, we send invalid data to the application to try to crash it, and that's one of the things you can do in the lab. A number of ways to do that. So the application should check all the input, and if the string's too long, I'm not a programmer, but my programmer friends say that one of the quickest ways to help with this is give the truncate command on the inputs, because the input should only be so long, and you don't just let an infinite number go. The objective of these things is to crash the application, crash the operating system, or execute some code on the system. The things that we can have are buffer overflows and the integer overflows. The buffer overflow, the buffer is a small area that holds instructions for the web page. What the attacker does in this case is overfill the buffer. That restores to expect, and that's where it stores expected data. So we overflow this thing, and when we can overflow the buffer, and this is being an unchecked input, when we can overflow the buffer, okay, it says I've been restored. When the buffer overflows, you can put your own data into the area. And it's allocated. The application can allow arbitrary code to execute with these things. And a stack overflow, the stack uses a return address. Code Red and Slammer used that. And what you do, again, you can get arbitrary code execution in these things. A heap overflow. A heap's where the variables are stored, so you can change the variables there. And an array index overflow, you can change multiple values at a time. The next one is integer overflow, which causes the application to calculate values that are out of bounds. And one of the examples that they gave is cause a positive number to be negative. A bank debit becomes a credit. If it were my bank, I would want it to go the other way around, that a negative number becomes a positive. But it could cause a crash or use in a buffer overflow attack. When you talk about these things, there used to be an attack, and it was unchecked for a number of years, I guess, where you could go into a website where you could buy stuff and you could actually change the price. They had people going in and changing the prices. When they got done, that instead of you owing them, they actually owed you money. Those have been fixed on all of them, I think. Web application exploits, privilege escalation. Having trouble talking again tonight. You get privileges from the process that's running to install malware. One of the things that you can do, and I think I put a link to a video, that when you start up Windows, you can click on it, you get the little help files. You can go in and change that to it because it runs at system level. You can go in and change that, boot to a Linux or even boot to a Windows DVD, go through the file structure, change that file to command.exe, click on it, it opens a command.exe. You can use the command line to now create users and give the users administrative authority, physical access when we do those things. Arbitrary code and remote code execution in the buffer overflow, and what we're looking for here is a method to execute his or her own code. Part of what Windows has done to fight this is it puts the buffers in different locations so that the process knows where it's going to go, but the hacker doesn't, and makes these kinds of hacks a little less significant than before. Remote execution is when the code will execute the code on another machine, obviously. SQL and XML injection attempts an SQL query as a part of the input. We may ask for a number of line numbers, and we'll get the username and maybe get the username and password in order to do those things. Pass the application SQL or XML commands via the user input for the URI. So we're going to execute commands through the address bar, which will then obviously allow us to do those things. Again, if it is unchecked input, show or insert information or code in these things. A directory traversal command injection is when you get a command prompt and you can actually see the file structure of the system. Transitive access, you compromise a trust relationship maybe between a web vendor and a web page, somebody that's selling on a web page, and the vendor, drop shipper, or whatever else, and you can then take advantage of the relationship there. Cross-site scripting is an attacker injects code into a trusted site. It can be persistent, non-persistent document object model. This is the process here where we infect with a script or infect some way, and again this requires that the web page be infected. We, the victim, then visit, it injects a script onto our machine, and then I like this one, do something bad. Something happens not good to our system. A lot of this stuff goes back to what authority are you running, or what authority do the scripts run out on the machine. User access controls properly configured, you should get a pop-up that says you want to install this. Before the user access control, where we're on the system but we're not actively administrators, before we had that, many users were out there on XP being administrators, which is not a good way to do it, and they got infected in a number of cases. XP was a good operating system, but unless you made yourself an ordinary user and used the run as when you needed to be an administrator, it became could become an issue. The browser exploits HTTP is stateless. And if you go back to, we talked about firewalls, we had stateless and stateful firewalls. A stateless connection is one that doesn't know about anything else. It doesn't know about any of the history of the system. And that's where we come up with cookies. Cookies can keep website configuration so that when you revisit it, you don't have to go through all of the configuration setup again. Session hijacking, it says cookies can be used and misused for session management. The XSRF, cross-site request forgery, passes the URI to another site to open in the user's browser. So these things, and we can have cookie stealing, cookie hijacking. Sometimes we save passwords in cookies. back to the LMS, Learning Management System, Moodle had to have cookies set because what it used was an authentication cookie as you went from page to page to actually maintain your authentication. So the session cookies, things like that, should be destroyed when the session ends so that you're not saving that information on the machine. Header manipulation passes corrupted header to the server to trick it into returning the attacker's code, and we've talked about headers before and those sorts of things. Web application design, the secure coding practices. Most of these guys don't want to create problems in the systems, but sometimes it does happen. And what we have to do is things that we do, input validation, where the inputs are validated. Are they valid? Are they the correct length? Are they going to have commands? Those sorts of things. Fuzzing is when we actually try to test, or we do test the validation routines and see if they work. Test it with a vulnerability scanner to generate large amounts of invalid random input to see what happens to the system. Client-side versus server-side validation. Where is the validation going to take place? We're probably going to have a better chance of getting it done on the client side, but it's sometimes restricted to just telling the user that there was some sort of a problem with the input instead of telling us really what's going on. So client-side validation winds up being done in a lot of cases. I'm sorry, client-side validation is the one that just says, yep, there was something wrong with your input, not what was wrong with your input. An error and exception handling should be something that just tells you there's an error without crashing the system. And they don't always do that. And then cross-site scripting and cross-site XSRF input validation can help defeat those things. And again, the ones that are really dangerous, cross-site scripting, had to be, we had to make some sort of a corruption. We had to corrupt the website in order to make it work. Web application vulnerability scanning, design reviews, look at the application attack surface. What have we created? What are the possibilities of it? And this is going to a code review, architecture review. Could be a group, could be individuals, could be specialists. The code review is an in-depth examination of the way the application is written to be sure that it's written and doesn't expose the application to known input validation and injection attacks. We may create a new vulnerability. We never know about that. The architectural review is going to look at the systems that the web server depend upon. Could include the operating system, database applications, programming language, all sorts of different things in that one. Back to the attack surface, we should be trying to reduce the attack surface and all of those things. One of the ways to find out about your attack surface, obviously, is scan the system, see what it has opened up, to see what we've done to the system. Web browser security, IE, they talk about as a popular one. I think that the other ones are becoming more popular when we go in. And they say, well, Internet Explorer is insecure and Chrome is more secure. Firefox is secure. If you keep track of these things, which one is more secure at the time really does change. I used to be a real Chrome fan, and then it got to be kind of a pain. I think they when they first started, it was a really quick, really good little browser, and then they tried to make it a lot of different things and wound up making it, I think, heavy and a little bit slower than it should be, although I've kind of gone back to it lately because Internet Explorer is starting to do some weird things to it. So we can configure these things to allow or not allow things that we want to do. Download scripts, files, and plugins. What do we want to do? For the file download, you can say yes, no, or ask me. Always do it, don't do it. Whether you want to run the scripts, which scripts you want to run. And a lot of times we just configure to run Java because it is so prevalent in so many locations. And over here, it talks about downloads, file download, enable. We can enable or disable font download, and there have been some attacks in fonts. There's been attacks in lots of different things, and the default here is going to be enable. The .NET framework setup we're going to enable. Miscellaneous access data sources across the domain, disable. Those types of things. When we get do you want to install this software, Adobe Flash, and Flash is really getting a bad name. It has vulnerability after vulnerability, and that's probably the one that's going to go away first. I think HTML5 is supposed to replace it, but we get the pop-up. We should get the pop-up to ask us if we want to do those things. The plugins and add-ons are going to allow us to become more susceptible to attack when we do these things. ActiveX, Microsoft's for providing interactive, quote, rich media, unquote, content over the web. It gives you really cool looking stuff when it runs. Got lots of motion, really rich content in the web page. But again, it has vulnerabilities and it has to be updated on a regular basis. Browser help objects, BHOs, dynamic link library modules for IE, extend the functionality such as installing an additional toolbar, which is what we really need in my opinion. The Java applets, programs that run within the Java virtual machine. Windows no longer ships Java as part of the original install. It has to be installed separately, and this is because of licensing disagreements. There's versions of Java for Linux, Mac, and Solaris. Shockwave and Flash used to be called Macromedia, popular with developers for providing interactive content like on a desktop through a web page. PDF, the portable document format, been around for a long time. It is when you're using documents, posting documents on a web page or things like that, it's kind of the universal document type that everybody should be able to open. The other one, Silverlight, which is not on the list, is Microsoft's version of software that does things similar to Shockwave and Flash. And code signing, one of the things that can help us with these things is signed code. And most of the configurations over here won't install unsigned code directly. So that's some of the things that we want to look at with these. Browser security in Microsoft, where the security zones, and we can change them the way we want. We've got internet, the local intranet, trusted sites, and restricted sites. Trusted sites, you have to add to them. You have to add them, and the restricted sites you have to add them. The defaults are, I think, somewhere in the middle of security. We have medium to high, and if you look at those things, you can modify the security. You can get specifically, you can modify individual parts of it. And this over here, the group policy editor, just shows that you can set these things up. You can, as an administrator, manage the browser inputs, the browser configurations through a policy if the machine's a member of the domain. So we can control, as the administrator, network administrator, the configuration of the browsers on the system. The cookies and privacy, again, the text files, select a setting for the internet as medium. It blocks third-party cookies that do not have a compact privacy policy. Third-party cookies that save information that can be used to contact you without explicit consent, and restricts first-party cookies that save information that can be used to contact you without your implicit consent. You can change the configurations of these things, and this has got, we can turn on or turn off a pop-up blocker. Disable the toolbars and extensions when you do in private browsing. In private browsing doesn't really store anything on the machine when you do those things. You can modify these things. You can clear you can clear the cookies. You can clear the browsing history, those kinds of things. And if you're doing private, it doesn't record the browsing history anyway. Applications should encrypt the cookies used for confidential data management, although that's not always going to be the case, but we would want it to be that way. Browser hash and autocomplete settings here, and it's talking about lunchtime attacks. I posted another video. If you see a password's got all the dots in it, and that would be the cached password for the lunchtime attacks when somebody didn't lock their machine. You can go into a web page, and with a right-click view, you can, and make one change, you can actually reveal the text behind the dots. Again, the lunchtime attacks are part of what those are going to be, and then flash cookies are also with us. Digital certificates we've talked about a couple of times. HTTPS, we need a trusted certificate authority to come from the site that we're trying to go to. If you get a pop-up about the certificate, there's something wrong with the certificate. It may not be anything dramatic. And I think I've said a couple times, if you go to the IP address instead of to the name, it's going to give you an error because the certificate has a subject on it. The subject is going to be the name of the website. And if it's different, it's going to tell you there's something wrong with it, with the certificate. You can look into the system, look at the certificate and see what it says and if it's expired, those sorts of things. But I think we've looked at those before. The review here is describe the technology used to implement web applications, understand the typical attacks that can be made against web applications, identify secure coding concepts, and harden web browser software and usage. Let me copy these things so I can go back and forth. Kevin said he's not answering questions tonight.
Skippy.
So we'll count him as absent. What is a persistent XSS is cross-site scripting. They didn't use CSS because CSS was already taken with cascading style sheets. So what is a persistent cross-site scripting attack? What do you think it is? Could be a long night if nobody's going to answer.
Eric's got this.
I know. Derek, where are you?
I'm here. I'm just doing something. Is it when I guess a victim trusts in a legitimate but vulnerable website?
Yeah, what we do is here we go. We inject, the attacker inserts malicious code into the back-end database used to serve content to a trusted site, or puts malicious code. It doesn't have to actually be a database. It puts malicious code on a web page. The other way that we can do these things, corrupt people, is obviously with emails. What methods should be used to protect a web server against cross-site scripting exploitation? What is the answer for anything to stop exploitation?
A secure website?
Secure website, strong authentication, and access control. Security aware application development so that we don't develop something that is susceptible to these things, and then testing, and that was the fuzzing. We can send a lot of data at it to see if it will crack under the pressure of being overwhelmed. Why should no SQL database format be selected for a back-end storage for a website? I don't think I was real clear on that one, so let me answer that one in one word: performance. They scale to meet the demand more easily than relational databases. It may also simplify application design, as the data schemas can be modified in an ad hoc way. Why might an integer overflow exploit in a web application lead to data loss? There we go. You can chime in too, Dean. Clyde, since Kevin's boycotting us.
I'm not going to answer. I said other people can take a chance tonight.
I know.
I think me and Derek should both boycott, and everybody else should talk.
Lee says he has no mic. Okay, go ahead and put in the chat.
Come on, pipe up, Lee. You got all the answers? He's asking what the question was again.
Okay. Why might an integer overflow exploit in a web application lead to data loss?
Because it causes values to be out of bounds.
Yeah.
They're going to make it to where it's not right.
Yeah.
The numbers are not going to be sequentially the correct way.
Yeah. And their answer is always that you could put in malware. I'll tell you what they say. The integer can be exploited to gain access to privileged memory. That's the case with all of the overflows. The attacker may be able to steal information or install malware. What type of programming practice defends against injection-style attacks, such as inserting SQL commands into database application from a site search form? What's going to help us out with all of our things that we input?
Input
Injection.
validation attack.
Huh?
I was saying the input and validation attack.
Input validation, yeah. And that's the
It's fuzzing, right?
programmer. Well, fuzzing is when we actually test it. Input validation is it checks to see that if it's something you would expect. Did we input a JavaScript command when we asked for a username and password? Did we try to get the directory structure? If we did that, it should reject that one. Say, not a valid input. If we have something that has to be numbers and we put in letters, it should tell us that we've done those things. So validation checks to be sure that the input is something that's reasonable within the bounds, and that's why the integer flow says that that calculate values that are out of bounds. The out of bounds would be the parameters that would be allowed values. And if we had input validation, if we got one of those out of bound values, it would then reject it. What type of security controls or programming practice defends against transitive access attacks? I'll do this one. It's a transitive access, and they calls it or confused deputy. Means that an attacker is able to exploit a valid session. A web application should be designed with secure authentication and authorization tokens to prevent this type of attack. Your company is developing a web application that will be deployed to Apple iPads. What part of the auditing process will determine the security requirements for deployment on the tablets?
Code review?
Yeah, it'd be the review, code review, probably actually architectural review is what I think they say for this one.
So no, Windows and Apple's totally different.
Yeah.
What do you mean? They don't all run off Windows? You're out your damn mind.
Blasphemy.
You just got to that one, huh? What vulnerabilities might error messages reveal? If somebody's really good and the error messages are really bad, it might reveal the workings of the code to the attacker. And sometimes you can get an idea of what they've done because it'll tell you that you haven't done this or you haven't done that, this configuration or that configuration is wrong. How does Internet Explorer choose how to trust certificates?
It has the great internet options scale there.
Yeah, but what about the certificate? Not just them. How do we choose how do we know if we accept the certificate or not, if it's valid?
It'll tell you. It'll actually say issued to, issued by, friendly name, all that kind of good stuff.
All that stuff. So it's got to come from a trusted certificate authority, right? I mean, that's what you were saying. When we look at the certificate is valid, but if it comes from a trusted certificate authority, then it's just going to say okay. And if the whole thing turns green and we know it's been a high assurance, we can really be sure that they investigated that. What restrictions should you enforce to prevent infection by malicious browser plugins?
ActiveX.
These are all.
Make
These
sure
are
all
all.
your stuff is updated.
But what's going to
Code sign.
code signing? We want it with a signed applets from trusted certificate providers back to the trusted certificate authorities in order to trust those things. So the objectives here are describe the different technologies and uses of virtualization. Virtualization is becoming a really big deal. It's probably the thing that's saving Microsoft right now. They've become, if not the biggest, one of the biggest virtual providers in the world. The other one, of course, is Amazon, which is, I always thought, kind of interesting. I had a student who worked at Rackspace. He's at a different company now, but they did a lot of virtualization. And you talk about people with a lot of servers. He said they owned 63,000 servers in their data centers. And they could spin up a virtual machine for a company in about 10 minutes, depending on whether you want Windows or Linux. Identify the security issues involved in virtualization. There are some, and there are some security issues that virtualization causes because of the way that we put machines together in the environment that we put them in. Understand the use and security implications of cloud computing, and we're probably all using cloud computing in one sort of another, either Dropbox or Google storage or something like that, storage someplace else. One of the issues with cloud computing is you don't really know where your data is. You don't know what country it's in. You don't know what kind of handling it it's getting, so it can have some real issues. So the virtualization technologies, what we have are the computer. The computer is going to be the hardware that everything, the virtual machines are going to run on. The hypervisor is the software. It can be either installed directly to a computer called a bare metal install, or it can be installed under the operating system. An image of kind of what, if I can get it over here, image of what this might look like. In hypervisor, or type 1, we have type 1 hypervisor and type 2 hypervisor. Type 1 is the one that's installed. This is the bare metal, the hardware, and the hypervisor. The hypervisor is installed on top of the hardware. And the type 2, the kind that we would run on our PCs, we have the hardware, the operating system, and then the hypervisor is going to be running on top of the operating system, and then the VMs are going to be running in the hypervisor. The bare metal is going to be more efficient because it doesn't have to worry about this operating system down here. It is the operating system. The guest operating systems are going to be the virtual machines, the VMs. So with the computers, the hardware itself, the hypervisor is the software, and then the guest operating systems in those. The hypervisor manages the guest VMs. It shares the hardware resources, and that's all a virtual machine really is. It is software that gives us the ability to share the hardware among more than one operating system at a time, and they don't even have to be the same. We could have a Windows machine and a Linux machine running on the same set of hardware. Doesn't really bother people to, on their computer at home, could be running an email client, a web browser, and maybe a word processor or a spreadsheet all at the same time, sharing the resources on the computer. And that's really all that we're doing with the virtual machines. Instead of sharing them within the operatings within a Windows, we're sharing it within the Hyper-V software that runs either on the hardware or on top of the software itself. manages the guest VMs, the hardware system resources, how much memory you're going to have, how much disk space you're going to allow. And when you get into these things, you get a pretty high utilization. CPU probably about 90% efficiency, memory about 90% efficiency, and I've actually found that you probably need a little less memory to run a virtual machine than you do a physical machine. Networking can become an issue if you have a lot of machines on the same server. If they're all doing something intensive, if you had a bunch of servers running on the same machine and you were sharing the same NIC, because it again shares the resources. So if you have a number of virtual machines with their virtual NICs sharing the physical NIC, there is a limitation to how much information can go across that thing at a time. But back to the efficiencies, disk images and snapshots. Disk images are disk utilization on the hardware is the thing that is going to be the least efficient. And it goes down to probably around 60% efficiency for the disk. So if you have a lot of disk activity on your VMs, it can cause some real issues. And that goes back to database servers. Do you want to virtualize a database server? Maybe not. Other things, we virtualized just about everything. We didn't have a database server. We virtualized our domain controllers because what they do, they authenticate you to the network. WSUS server, the antivirus software server. Trying to think of the other ones. The DHCP server, the DNS servers. DNS obviously is part of Active Directory, but the virtual environment worked very well for us. Not a real busy network, but a lot of people are going to virtualizing their environment or virtualizing part of their environment because they figure that, for one thing, they don't have to hire as many IT people. Not necessarily good for those of us who have or trying to get into that community. And it says security and sandboxing, and the book says ensure that guest OS are contained or sandboxed and cannot access other guest OS on the host except through authorized mechanisms. And that can become an issue when we talk about who may actually be in the same environment as you are. And then we have the host-based versus the bare metal. We've looked at that. The host-based is probably, it's going to be less efficient than the bare metal because it has an operating system to contend with. CPU support for hardware virtualization will boost the performance, and the newer machines, the newer hardware have that capability. It doesn't necessarily mean that you can't virtualize on those machines. I have some old hardware. I can run a Microsoft Virtual PC or Adobe Workstation, or but I can't install on my operating system Hyper-V because my CPU doesn't support virtualization. Some of them come with it configured, ready to go, some with it disabled. Some older systems don't have that support. It allows the hardware better performance of the system, required by some products, required by Hyper-V in Windows.
You must have an Intel processor.
Well, I don't even know what I have. It's old processor. Yeah, well, all the newer Intels and AMDs have it. AMDs, I think, has had it longer than the.
No, actually, not all the Intels do. They actually have specific ones that specify if it does have Hyper.
That's true.
Or not.
That's right. That's exactly right.
It has to say it has virtualization.
It does. Has to say, he's right on that. It does have to say that, and it may be disabled in the BIOS by default. You may have to go in and enable it.
Well, in the Intel platforms and everything, if it's meant to be overclocked, it will not have virtualization. If it's not meant to be overclocked, it will have virtualization.
Yeah, yeah. Overclock and overclock and overclock. Yeah, obviously you can do that. I'm not sure with the speeds that you get from the regular processors today, you really need that. Some of you gamers probably do. I don't need anything very powerful because I do like PowerPoints and word processing, email, and web browsers. Don't do any of that high-powered stuff. But yes, if you're going to do that, you need to check it to be sure that it does work. The place where I worked at before, we got a server specifically for virtualization. I don't remember yet. It had 96 gig of memory, 2 quad-core processors, and a couple terabytes of RAM, and then we put a storage area network onto it to have more storage. Virtual machines really didn't work all that well off of the stand, but we could store the images there that we use to create the other VMs, because you can create one virtual machine from another one. We actually ran, and they talk about 4, 5, or 6, and that's probably the ideal on those things. But in the training environment, we had, I don't know, I think 95 virtual machines running on it at one time. So if you don't have a high load, you can get a lot better hardware utilization, and that's one of the reasons that people are going to virtualize, is because the hardware costs are reduced significantly. You still have the licensing costs for the operating system itself. Heat generation is a lot less, and that's one of the big deals. If you get a lot of servers or a lot of machines into a small area, is how you get rid of the heat. Don't really have that severe a problem with virtual machines. You get better hardware utilization, and one of the things that I'm probably doing most of the lecture hopefully right now, when we do that higher virtualization, the hardware may fail sooner because CPU utilization is typically somewhere around nothing on a server. Well, maybe 4 or 5, 10%. And now if we're running at 80, 90% utilization, CPU may fail quicker. So those are things that you really do have to take into consideration. Again, a lot of people are just going and buying virtual machines someplace else, Rackspace or Amazon or Microsoft, those kinds of guys. Desktop virtual platforms, mostly host-based hypervisors, which means it's going to be running on top of the operating system. Virtual labs, virtual research, and sandboxing are things that we can do with these things. We can create a research lab, we can analyze things, virus research, what goes on, and this is one that we can set a machine out into an environment and let somebody attack it, and if they get a virus, big deal, you delete it and go on, move on, start over. You may need it to support legacy applications. Windows 7 had the Windows XP virtual machine that you could install on it. It didn't come by default. You could also put one of the other softwares, a virtual PC or the workstation, VMware workstation. I said Adobe, VMware workstation on the system to run those things if you need. The advantage of the one that ran on Windows 7, it actually integrated into the operating system where it would use the hard drive and all, and the software that was installed on the 7 machine. Can use it for a software test environment, what works and what doesn't work. We can use it for one of the things we talked about in updating. We can use it to test the updates to be sure that they're going to work. There are softwares available. If you have a hardware, you can go from hardware to software. You can create a VM from the hardware, or you can put a virtual machine onto a set of hardware. Use it for security control testing, and one of the things, and that's what you guys are using right now, use it for training, use it to do learning on. And this system actually spins up, creates those virtual machines from a template each time that you log on to them. That's one of the reasons it takes so long to get them online. Server consolidation is one of the things that we can do with virtual machines. So that's kind of what we did, is we virtualized, I think, probably all of the servers except for the one that ran the training, the VM, because you couldn't do that. You get better hardware utilization. We've talked about that. Better energy efficiency, because we're not running as much hardware. We're running the hardware harder, so it's going to individually consume more energy. But in the aggregate, with the number of computers we're using, the energy consumption should go down. Talk about need to choose candidates for server consolidation carefully, and you do. Which servers are you going to do? And one of the other things that happens with virtualization is that we start to get virtual machines spread. We're going to virtualize this, we're going to virtualize that, and we make a whole lot of different virtual machines that we may or may not need at any given time. VDI, the virtual desktop infrastructure, is something that is become kind of popular, and it allows you to use hardware long after its life expectancy. This is one of the other things that we did. We took a server and we put virtual machines on it, Windows 7, and I had a Windows 10, but Windows 7 machines on it, and used hardware that would barely support XP. We used a Linux remote desktop, a Linux thin client, or a Linux system that actually booted, started a remote desktop, and logged on to your computer. And we were running on, again, hardware that there was no way it was going to support Windows 7. And we're running Windows 7 machines in a number on a number of very old desktops. Images are loaded by thin clients. The actual thin client itself is a small piece of hardware that has maybe usually they have a Citrix client and a remote desktop and a browser in them, and that's about it. They have a keyboard, mouse, and a monitor. And what you can do with these things is run remote desktops like I was talking about earlier. We have the virtual machines all on a server, and then the individual logs into their computer via a remote desktop. Now, downside to that is if we have a server failure, we just lost a whole bunch of computers. If you don't have some sort of redundancy. And when you start talking about redundancy for virtual machines, it can be done. There are processes to do that, but it takes an awful lot of storage to do that. So it allows the low power client devices, what I was talking about earlier, a little Linux installation running a remote desktop, and all the processing took place on the server itself. Centralizes control over the client desktops, and that's kind of a good thing and a bad thing. Actually, we can do the backups. We can do the backups of the images. If something happens to an image, you can make a new one. And if you have a system to where people actually store everything on their home directory central location, which is also a convenient way to back things up. If something happens to the virtual machine, not a big deal to spin it up. We can make it from a template very quickly, and all of the applications are already installed and it's ready to go. Updating may become an issue, although ours was set up to go to use the WSUS server. Microsoft allows you to mount the image and add software to it. You can and update it as you go along. Allows for almost completely hosted IT infrastructure, software as a service. When we do that, the virtual desktop infrastructure. We have virtual applications, and they've been around for quite a while. Citrix does that. What Citrix really is, I mean, it runs applications. What Citrix really is a remote, typically is a remote desktop with a Citrix client laid on top of it to give us a nice look of what goes on with the system. Hosting, streaming individual software applications on a server. This is when we're just doing applications. XZen, AppV, and then and ThinApp allow those things. And we can use terminal services. Terminal services has been around for a long time, and terminal servers were able to stream. It was a stream application. The application looks like it's installed on the desktop, but it's actually running on a server someplace else. Storage virtualization. Storage servers actually use virtual hard drives. When you go in, you have the physical drive, you create a virtual hard drive, at least the Microsoft one you do, a virtual hard drive inside of it, and control, the OS passes control physically locating data on disks to a virtualized layer when we do these things. An advantage here, we can use data deduplication. What it will do is preserve one physical copy of a file that appears many times, and you can run data deduplication. It appears many times on a system, and this is going to be exactly the same file. And what you do is keep one copy of it, and each of the other multiple copies are then has a pointer that goes to the single copy that we maintained. If you create your own version of it by making changes and it's no longer unique, then you would have your own copy of it. Then we have the energy efficient storage hierarchies. Online is going to be obviously on the machine itself. Offline might require a physical interaction to access the data, such as pulling a tape into a drive or something like that. Nearline may be a tape loader, similar to some of the stuff we talked about in backup. Online is going to be with the disk that's on the machine. Virtual networks, guest OSs can have more than one virtual network adapter, and the number depends upon which operating system you're running. The one that I was using, and it was a 32-bit system of Microsoft one, the Microsoft product, allowed 4 NICs on a single machine. And what we did for isolation was we had our virtual networks, and we had 3 or 4 of them, or however many we wanted. If we needed more, we could create more. But we had our virtual networks, and we used 3 basically for isolation for the classes. 3 networks that went to the 3 NICs, and then had the 4th NIC was our quote public unquote NIC, which went to the school's network, so that you could get in and out. You could get on the internet, so you could do updates on the servers and get software's updates and those sorts of things, and do things as if you were in the actual real world to keep systems up to date. The guests can be connected to VM-only networks or join a host network. You can set it up so that it's a network that stays on the virtual machine, and only virtual machines that are on those networks can talk to each other. The Hyper-V, the networks themselves implement virtual switches, so you can have multiple machines connected on a single virtual switch, which becomes a VLAN, and they can talk to each other. But if you're going to communicate with another virtual switch, another VLAN, you have to have a router in the system to do that, and be a virtual router. You can use a Microsoft server in order to do that, since it's virtual machines, depending on how much your licensing requirement is. Educational licenses with Microsoft are very liberal, so we could basically do as many as we wanted. They kind of charge you by the student. Pros and cons, some of the stuff we talked about. Energy efficiency reduces the amount of physical space that we need for servers. Allows us to repurpose hardware in a desktop world. You can buy the thin clients and install them. And another advantage to thin clients is they don't really have any moving parts. The operating system is embedded in them when you start them up, and then you start either your remote desktop or your Citrix or whatever you're going to use to connect to your VM. We have administrative control over the systems. And then for disaster recovery, they are from images, so you can recover as long as you have your images someplace. You can recover relatively quickly. To me, the issue for recovery would be recovering the data, and that would mean that we would need to have it backed up off-site so that we could recover the data that people were using. But the restoration of the network really does become quite a bit simpler with virtual machines. The other thing, and one of the other things you can do, and I'm sure that I'm ahead of myself, but or behind myself, we can take snapshots, and snapshots of picture in time stores that condition of the server. When you quit your labs and say save it, you're really kind of getting a snapshot there, what it does, and then you come back and it restores you to that point in time. To me, an advantage of a snapshot is if you're doing something that you know may not work, that you need to undo, take a snapshot. If it doesn't work, use the snapshot. It'll reset you to that point in time before you started making the modifications to the system. I was trying to upgrade a server one time and it wouldn't work. Because every time I do it, it says, well, you can't upgrade it with this on, you can't upgrade it with that on, you have to take them off. So each time I had to take them off and start over with the update, and it may or may not work. So I finally started doing snapshots. Undo disk is what it was called at the time. So that when I did something that didn't work, I could just use my undo disk and go back to the point in time before I started that. Hardware and software training investment and performance and security are part of these things. Performance may or may not improve, and it may or may not degrade. Security may be an issue the way we set these things up, because if you're not hosting the network itself, the private network itself, you don't really know who else is in that environment on that server with you. Could be somebody's putting a virus up there for you to get on your machines. Performance and host elasticity. Virtualization carries overhead. That does impact performance, may impact performance. Sometimes I thought some of the machines actually ran faster. One of the issues with Microsoft is they don't really have good support for Linux. There's a real shocker, although they're starting to get better at it and to get to where
they don't have good support for anything.
Well, they actually do for the virtual machines for themselves. The tools that you put on to the virtual machines do a much closer mapping of the software to the hardware. But they haven't done a very good job. They had one early on for SUSE that made it work better. Linux works great on it at the command line, but if you start running the GUI, it really becomes ugly quickly. Like the mouse won't move in the right direction, things like that. Resource contention, overutilization. We have we have many machines running on this virtual machine, So we may have resource contention. Overutilization, too many machines trying to use the same resource at the same time. That can happen. I used to have occasionally on an old virtual machine that we had, doing a final exam, a final practical, a bunch of people starting at the same time trying to install Active Directory on Windows servers. And it's one of those that sometimes would start and everybody's trying to do the same thing at the same time and can't write back because everybody's trying to use the disk, and the disk utilization was the worst. So it's a matter of just getting it going and going away, doing something else, coming back and letting it do what it needs to do. Host elasticity, we can add resources to the host elasticity, add resources to the host to modify the systems that we need to do. So they say virtualization offers a more efficient performance if the original server was underutilized in the first place. And that is true. Again, what it allows us to do is a better utilization of resources. We can run multiple machines if we don't have a very busy server at the same time. We may have increased load, LOD, on the network node. May become an issue because we have one physical NIC. Typically, you can have more if you want, and you can then connect the different machines to the different access points. Single points of failure, talked about that. If a virtualization server goes down, you just lost a whole bunch of computers, access to the computers. It doesn't necessarily mean that they've gone away, but you have to do something to recover from that. Security, again, single point of failure, greater impact of failure. One hardware failure causes numerous servers to fail. Meantime, between failure, the failures may increase as you have, again, a higher utilization of servers. Denial of service, we can take a whole bunch of machines out of service really quickly on the same server, and these can be done internally. People, if you unplug the NIC, none of them can communicate. Turn the power off, do a denial of service on the server that hosts the machines is something that that can cause some issues. Provision redundant servers, we can do that. There is a way to set these things up so that they automatically back themselves up or become redundant, and this would be cloud computing. We would want to do that someplace else, because hopefully the only reason we would need the redundant server is if we had a disaster of some sort. Not that we want a disaster, but we don't want to have to necessarily use those things. We have an additional layer to attack in the Hyper-V. VM escaping here is malware running on a guest OS jumping to another guest operating system. If we go to a provider like Amazon, we could have a private network, it could be on a public network, or it could be on a community network. The private network, we're the only one on it. The public network, anybody might be on it. The community network would be somebody else that we knew would be on the system. Details of the hypervisor may be opaque to the network administrator, and the resources may be shared with unknown other companies if you're on a public network. Physical and virtual network boundaries, and this is a nice picture. We have the host, middleware, backend services. We have virtual switches that we connect the devices to, VMs and the virtual switches, and I think that really, unless they've changed them a whole lot, the virtual switches, they call them virtual switches, but they're kind of virtual hubs. You can do scanning and all the normal things that you would do on physical hardware on these things. The guest OS, patch compatibility management, the guest operating system has to be compatible with what the server supports. The operating system environment's got to be maintained. We have to continue to update the systems as we operate them, just like you would a regular machine, because it becomes a regular machine. It's just something that is sharing the hardware of the device that it's running on. Rogue virtual machines is installing unauthorized virtual machines because desktops allow that to happen. One of the ways that we found to do that was to keep them off of the desktops. One, they probably didn't have the authority to install them. So depending on how you had your user set up, but if you use hardware filtering on the switch and you get that second MAC address, it'll shut down the port. So you could only have the machine that was authorized to be running on the port there. IT infrastructure as a service. When we do this, we're basically going out and buying some parts, all or part of a network. The IT infrastructure, the thing that it allows us is elasticity, and the examples that they always give is you're running a store, for instance, or a website, and you have a certain demand through the year, and it gets to be Christmas and you need more. You go to the provider and say, okay, put another machine on for me, and they can do that. Pay per use, instead of having hardware and network resource that you're not using, you only pay for what you're using. The deployments of these things that can be off-site or on-site, and these are the things we were talking about earlier. It can be public, hosted private, which is a private network hosted someplace else. Private, which would be a virtual network that you host yourself. Community or a hybrid. Hybrid could be a mixture of those. If you're doing the off-site, you need to, I think, be aware of the public, because you don't know who's going to be on the rest of that infrastructure with you. Hosted private, problem here would be it's going to be relatively expensive. Private, you're going to have to run your own hardware to run your softwares. In the community, you're going to know who you're on the system with. We have these as a service, and what we do is lease from a provider some elements of our network. We could have infrastructure, networking, software, or platform as a service. Infrastructure is you basically buying a whole network. Provisioning the IT resources, servers, load balancers, storage area networks, networking itself, the whole thing. What we're doing with it as a service here is leasing it, meaning you're not having to buy an IT staff. Somebody else has the IT staff and has responsibility for a lot of these things. Network as a service. With this one, we're going to have the basic network infrastructure required to provide internet connectivity from these guys. Software as a service. I think this one would be something like if you have a web server, that because you only have that software that you're running, and you have that as a service. You're not running the web server. You're setting up a web server one-on-one, GoDaddy or someplace like that. Platform as a service, they provide you a computer, a server or a workstation, whichever you want, but usually going to be a server, and then you're responsible for configuring the server. The risk, we transfer some of the risk with a service level agreement, an SLA, where the other guy agrees to do certain things, maybe provide security. And in that, we have to identify the responsibility, verify the provider's performance of the tasks. The legal responsibility and regulatory responsibility are still going to remain with the company that always had that responsibility. The insider threat from the service provider may be an issue. You don't know, and you do want to know what kind of checks that they have done on their people. So there are certain risks that go along with virtualization, particularly if you virtualize off-site. So to review is describe the different technologies and uses of virtualization, identify the security issues, and understand the use and security implications of cloud computing. So who's participating in questions this time?
Clyde, he's over here telling me Clyde's going to talk today.
He's telling you what?
He's looking at me like, you're out your damn mind.
Yeah. What is a hypervisor?
Computer.
What is a hypervisor?
The program allows multiple operating systems to share a single hardware host.
Yep, exactly. It's the software that allows us to run the virtual machines. What methods can be used to allow communications between VMs on a host? I want to do this one because I didn't say all these things, and I honestly didn't see it in the chapter either, but it says hypervisors support features such as clipboard sharing, folder sharing, and non-persistent disks. It can also communicate over a network connection, which is the one that I've seen consistently. The clipboard sharing and so on, I have seen that between the virtual machine and the physical machine, and I've not personally seen that between virtual machine to virtual machine. It does say the VMs and the host. Okay, so yeah, you can share all that stuff with the host. Not necessarily a good idea, but you can do that. What term is used to describe a computing architecture where thin clients are used to access images of client operating systems stored on a server?
That's your virtual platform, right?
Yeah, VDI, yep. And they call it virtual desktop infrastructure, but virtual platform. That's what we're using. That's what a lot of people, a number of people are starting to use. And if you go to some of these big storage companies that big storage, they're talking about hundreds of desktops that start up. They say they start starting those things up like 2 o'clock in the morning for an 8 o'clock start time. What is server consolidation?
That's the bare metal platforms or server class host hypervisors.
Yeah, hypervisors, what we're going to do is convert virtual or physical machines to virtual machines and put them in a virtual environment. Why might virtualization support faster deployment of applications?
It's already kind of set up in there. You just got to get it out of the computer. It's already ready to go.
Yeah. What you do is you create the image, and you create they call it a gold standard, typically can call it your gold standard image that has all the applications that you need, and then you make the rest of your virtual machines from that. You have to, in Microsoft, strip out all the security information. If you don't do that, you're going to wind up with a whole bunch of machines with the same SID, which won't work very well. But you make one from the other, you can either copy them or use it as a, and they talk about differential disks. I've seen differential disks run in a different way, where you have a base machine and then you create a differential disk for the new machine, and it only records the changes. And all of them can run from the same base disk in that instance. What is the risk of VM escaping? But you would have something for that, Kevin.
Chime in. I'm brain dead today.
Okay. VM escaping. I mean, I thought you had something. The danger would be to have an accident or something. What is VM escaping? I remember talking about that. I can't find it though. It's when, if you have one of these, here it is, one of these public.
That's your personal, public, and yeah, community.
Yeah. And if you're on one of the publics and somebody puts a machine up that has a virus, a malware, and the malware jumps from one machine to the other. Text may steal information, perform denial of service, infect the system with malware, and so on. What's a snapshot? If you take a snapshot with a camera, what do you get?
It's like a screenshot.
It's like a screenshot. It's an image. It's a what's there at a point in time. Let's see what they say. A guest OS is stored in an image file. The single file represents all the data stored on the guest OS hard drive. Disk images can be used as templates to set up new VMs quickly. A snapshot or differencing disk is a copy of the disk image at a certain point in time. Snapshots can be used to roll back changes made during a VM session, and that's one of the big things is you can make the snapshot. If something happens that's not good, you can roll it back to the time of the snapshot. What is meant by public cloud?
A cloud that's used for public?
Well, kind of, but it's what Dean was talking about a minute ago, that we have the public, the private, and the community. So it's hosted by a third party and shared between subscribers. They call that multi-tenant. This sort of cloud solution has the greatest security concerns because you don't know who's in that environment on that server with you. Different from the private, which you own the whole environment, and the community, you know who you're sharing it with. What type of cloud solution would be used to implement a SAN? In this stuff, the infrastructure network, software or platform, the as a service.
Would be a platform, wouldn't it? Because technically, it's providing a service.
It could be. I think it could be. It's technically providing a service. Could be an infrastructure, though. We usually think about infrastructure as the networking and all that other stuff, but that is part of can be part of the infrastructure. Describe a key consideration that should be made when hosting data or systems via cloud solutions provider. So what would you want to get straight before you put your machines with somebody else?
Who needs to be where and why?
Who needs to be where and why? Who's going to do the updates? What kind of privacy, what kind of compliance are you going to do?
Your SLA and everything.
SLA, all that stuff, yeah. And the SLA should describe in detail what's going to happen with these things. Are they going to do the updating? Who's going to do the updating? Who's going to update the operating system? Who's going to update the applications? All of those things need to be solved before you, or resolved before you do anything with them. So this is 5.1, site security, and the objectives of it are: describe the use of physical security and environmental controls in planning and implementing site security. Identify the key features of environmental and fire suppression systems that impact security. And hopefully all of you Navy guys will already know those. Site layout and access, layers of security. What this really means is you need to plan your building to allow the secure areas to remain secure. You don't want traffic through secure areas. You don't want traffic around that's going to see the secure areas. So in this one, we've got zones with different security controls and access levels. We're going to with different zones, and this is showing, I hope, the different zones. We have the public area, which is going to be out here in front. That kind of makes sense because that's where you want people to come in. You don't want them to go any farther unless they're escorted. The private area where employees are going to be are around here. And then we have the restricted area on the outside, and that's the way they decided to do it. Is that the best way? Don't know. I think that this is one that aren't any real exact right or wrong answers. You want the restricted area to be as deep within the organization as possible, physically as deep within the organization as possible. So you might be able to make something like maybe restricted or area here, or private area here, and then restricted area back here. Depends on how your organization's set up, how the building's set up, where you actually need people to be. The zones, they have different access levels. You need control as you go from one zone to the other. Maybe badged with an RFID tag so that you can only get into the restricted area if you have a badge that rates you getting into the restricted area. And everybody should have ID badges. That's one of the things, and it's kind of hard to enforce in some areas, kind of not hard to enforce in others, depending on how the company thinks about security. But everybody should have badges so that if you find somebody wandering around back in these areas without a badge, you can challenge them. If you find somebody wandering around in one of these restricted areas without the correct badge, then you can challenge them. So the ID badges should be coded in some way, probably color coded, to show where you're allowed to be without escort. And that people that come into the public area get a visitor's badge, and they are required to have an escort wherever they go, and they really should never be, except in very special circumstances, in the restricted areas. Barriers and access points, some way to control, and they show little access points here, some way to control entry into each of these areas. Could be, again, could be a guard, could be a badge with an RFID tag that opens an automated lock, but you need some way to do that. The site layout, surveillance, probably going to have CCTV surveillance throughout the building. And when you do that, those are typically going to be on a motion sensor, and then they'll be recorded as well as seen. You need to be sure that the pictures that you get from it give you what you need to see from those systems. Traffic, how you're going to allow, what kind of traffic flow are you going to have. You really don't want people passing all these restricted areas. Curiosity. Probably want signage here to tell people to get out. You want your, or keep out. You want your, yeah, to get out. You want your restricted areas to be not as obvious so that you don't pique curiosity and people try to get into it. Fencing, you may or may not have a fence around the building depending on the security requirement. They say that if you do have a fence, it should be one that you can see through so that guards can detect or see somebody trying to climb the fence. You may have the razor wire, concertina wire on top of it in order to discourage people from trying to get over the fence. Problem with fences, it really does, especially if you do concertina wire, it makes it look like a prison. So kind of drab. You may or may not may find some better way to establish the perimeter of the system. Gateways and locks, I think that this has been in a lot of places before, and it's in a lot of the courses. One of the oldest securities is a wall with a door in it, or a fence with a gate, and those are the things that we typically see. And to secure the gateway, the door, you got to be fitted with a lock to be able to access the system. And we have conventional locks, prevents the door handle from being operated without using a key. These are things, and the one-way things, when you start talking about how are you going to secure your knock, you need some sort of a pretty good lock, and something that hopefully won't be left unlocked so that anybody can get into the system. A deadbolt, we've done that. The little bolt goes inside the frame of the door. Separate handle. We can have electronic locks. Instead of a key, it could be operated with a pin or an electronic keypad, cipher lock, and that's what we have over here is the cipher lock. Pushing the code. The problem with that is we've got shoulder surfing issues again here. Somebody watches you punch the code in. And probably tailgating you, they watch you punch the code in, you open the door, and then they go in behind you like they knew like they belong there, and that's where the badges come in. Do they have a badge that actually lets them into this area? Do they belong to your company? Smart card may be something like with an RFID tag, or that inserts into the lock that opens the locks. I was at one company that our badges were the only ones that allow us to go into the basement on the elevator. And everybody wanted to ride with us on the elevator because the basement had a shortcut to the parking lot. Could have biometrics of some sort, a fingerprint reader, and some of the shows have the iris readers, or some sort of a biometric could be there. We could have multi-factor where you have to have one of two things, something you have, something you know, or something you are. We can do those things. Turnstiles and man traps. Turnstiles kind of the not as expensive solution to trying to prevent tailgating. So they only let one individual pass at a time. Man traps can be relatively expensive. What you do is you have one door. When one door opens, the other one locks, so that they get into an area that they're trapped. They can't go either way. And so if something is wrong, or you can check that. But what it really is designed to is allow only one person at a time to go through a system. And then we have unauthorized entry points, and those are always going to be the smokers used to go out and they put a card in the lock or something so they could come back in, and it didn't lock. So those are other things that you need to be aware of in these systems. We got fail-safe and fail-secure locks. safe lock fails open. A fail secure lock fails locked. If you're using fail secure locks on doors, they can only fail secure in one direction. You have to be able to get out. You can't stop the egress. The problem with the fail safe locks is they now have opened everything. So you can have one of these two types of locks. Alarm systems, the circuit can be open or closed. It can detect intrusions through a barrier. A number of different ways that we can do these things. We can have motion detectors. We can have the circuit open or close, kind of like the one that if you have a home system that's on the windows, it has the little sensors, and if you open the window and don't have the alarm turned off, it goes off or it starts the alarm because you've broken the circuit to that device, or doors have the same thing. Detection intrusion through a barrier, the barrier being the door. Motion sensors, radar or infrared, detect intrusion in a space, and those are things that you kind of have to set up right. If you have pets, and this is for your home, if you have pets, you want to set it up so that your dog doesn't start things off. We had a glass break alarm one time, and a Christmas ornament fell off the tree in the middle of the night and set off the glass break alarm. It was a good idea, and we didn't have any other problem with it, but different kinds of alarms can do that. We have duress alarms, fixed or mobile. If there is some duress, then it goes as a duress alarm, and the receiver knows that the alarm has been activated through duress, so that they know how to approach the situation instead of blasting in. Other surveillance, guard dogs, which you may or may not want. Many of you probably have dogs at home. They kind of become guard dogs because, or at least ours do, because they alert on anything that comes in the yard, sometimes including us. Security guards, the issue here becomes you got to train them, you got to pay them, and all that other stuff that goes along with it. And people today in industry are trying to have as few staff as possible. But security guards, the other issue with guard dogs and security dogs is that they may again give the appearance of the prison type appearance. So you need to be kind of aware of those. Back to dogs. Guard dogs, actual real guard dogs, are very expensive to train. We have video and CCTV where we monitor what's going on with that. Lighting is always a good deterrent to keep people away, and lighting, motion sense lighting is also something, but lighting is one of the things that really does help deter people from going into places that they shouldn't be. One of the places that I work, one of the rooms that were occupied or not occupied, they said turn the lights off and lock the door. I always thought that was kind of not good. I always thought you should lock the door but turn the lights on, because if you turn the lights off, somebody gets into the room, then you've accommodated them by not being able to see them. Physical access logs, where you log people in or out, or actually the RFID tags, the software will actually log each time an individual went through a door. They actually did catch a burglar at one of the places that I worked because of this logging. Somebody was stealing stuff, and it actually was the guy that put the alarm in, so he should have known better. But the badges had a trail. The open and close with the badges are coded, had a trail to where the things were taken. The staff education and training about physical surveillance and the challenge policy if somebody's in an area that they shouldn't be in, visitor without a badge or somebody with a badge that's in the wrong area, they should be challenged. It's one of those, if you see something, say something. If somebody's in the wrong place, who are you? What are you doing here? Kind of deal. Hardware security, and this shows lockable cabinets. This big thing here, we put our machines in here, locked cabinets to keep the servers inside. Device locks are there. We used device locks one time. They're pretty ugly. They're another one that kind of makes it look like you don't trust anybody. So these things can all make you secure, but sometimes the image that you project can be an issue too. Safes to store those things that need to be there, and then protected distribution. How are we going to send a number of things to different locations? Site location, accessibility may be an issue. If you have someplace out in the country, that's all well and good. Make it less accessible, but by making it less accessible, you're going to be far away from everything else. Carry some risk. There are other risks that are involved in utilities, electricity, water, things that we really don't have a whole lot of control over and may or may not be able to provide long-term backups for. Natural disaster hazards, flooding, tornadoes, hurricanes, high wind, those types of things. And then in the building control, things that we kind of can control, dust, temperature, and humidity, all through our HVAC system, and dust filtering, obviously. Dust on the machines, on the electronic components, can serve as an insulator, and if it does that, it can cause the components to overheat. So you may need to take a server down occasionally, and you have to time that, obviously, and clean it out because of the accumulation of dust in it. The hot and cold aisles, what we're going to do is optimize airflow here. And what we have are cold aisles here, which are going to be the front of the machines, and the hot aisles here, which are going to be the back of the machines. What you don't want is the hot air from one machine blowing into the intake of the other machine, because what we want to do is have air go across through the case, drawn in the front and out the back, in order to cool the system. Don't allow contamination of the cooled air with the warm air. So we want the hot aisle, cold aisle arrangement for these things. RFI and EMI are problems. RFI, radio frequency interference. We humans create a lot of these things, and RFI can be things like the power cabling, motors, microwaves, anything that can emanate a radio frequency signal. We're going to have competing devices. You can have multiple access points, Bluetooth devices. In the wireless world, microwave may be competing or interfering with the wireless access point. You may have remote devices, game controllers, portable telephones, not cell phones, but portable telephones can interfere with these things. Can cause data errors or actually perform a sort of a denial of service in wireless communications. EMI is electromagnetic interference. It's caused by cabling in close proximity to the noise source. we at one time, one place had a power conditioner that was in the middle of a lab, and back during the CRT days, if you set a CRT machine close to it, the image became nice and wavy on it. In those areas of high interference, you're probably going to use fiber optic cabling or screen copper. Fiber would be the preference there. The screen copper would be better, but the fiber should be immune to the EMI. Fire prevention, the best thing is about fire is to prevent it, not detect it, and not put it out. But regular inspections, and the fire marshal's probably going to come around and inspect an occupied building on a regular basis. So you can do your own inspections, they're going to do their inspections, and they're going to look for fire hazards, obviously. We need to control the ignition sources and the flammable material, and then have fire doors. You also, well, in the we'll get to the emergency plans. Detection, smoke alarms, flame detectors, and the ones that are the more efficient, the flame detectors, let's talk about, they're going to be more expensive. We do need, and I think it's probably going to always be a requirement, to have some sort of smoke detectors or flame detectors. The types are photoelectric, measures the integrity of the internal beam of a light, what it's looking for. It's got a beam of light, and if it gets to where it gets cloudy enough to block that, it figures that it's smoke, and you get an alarm. Ionization smoke detectors, probably the ones like you and I have. It has a radioactive source that creates a movement of ionized particles, which can be disrupted by smoke. And then a heat detector, if the heat rises to a certain point or the rate of temperature increases, then they will alarm. And then a flame detector, use infrared sensors to detect flames. They're the most expensive, but they're also the most effective. Emergency procedures have an escape and an evacuation plan, and there should be maps mounted so that people know what their escape route is, and everybody doesn't try to use the same one. Typically, they'll want to go to where they know or where they feel comfortable, which may not be the best escape route. And if you have, when you have escape routes, you need to know alternatives, because if your route's blocked, you need to know another way out of the system. Drills where you practice the emergency escape are things that also need to be done. Fire suppression, we have the fire triangle, and they talk about now a lot of it's the fire pyramid because there are other things involved. I heard it was free radicals for a year, but there are some interactions in a fire that may make it more significant. So some fires involving chemicals can be sustained by the chain reaction, and the chemicals involved and cannot safely be extinguished by normal means, so you need to be aware of those. The fire triangle, heat, oxygen, and fuel, take one away and the fire goes away. That's been what we've talked about for years. In the sprinklers, we have a couple of different types. Dry pipe means that we have dry pipe and wet pipe. Wet pipe means that the water is already there. Advantage is that it will immediately start to extinguish the fire when the sprinkler is activated. The disadvantage is that you can have ruptures of the piping, which could flood. The sprinkler heads could fail, and those types of things. A dry pipe, used if you have a freeze hazard or things like that. The dry pipe doesn't have water in the piping itself, but it's filled when the sprinkler system is activated. The to me, one of the big disadvantages of the wet pipe is that the water's been sitting there for years in some cases. It can be pretty nasty when you do these things. A pre-action system fills with water when an alarm is triggered, and it will then spray when the heat rises. Halon at one time seemed to be like the greatest thing because it would put out fires and wouldn't damage humans. But then we found out that it damaged the ozone layer. So they're not putting any new halon systems in. The ones that are currently installed can remain installed, but you can't use new ones. Ships that I was on, it's been a long time, but we used a halon suppression in the gas turbine compartments, and it was one that was a lot better. There also had some CO2 flooding, and CO2 flooding is not good because you need to be sure that the space isn't occupied before you activate it because it will kill people. Clean agents, the alternative to halon, it's the new one. It's not toxic to humans, and it's not environmentally damaging. So there is a replacement for the halon that we can't use anymore. The fire extinguishers themselves, what kind of things do we have? We have Class A. Class A are common, paper, wood, those sorts of things. Class A are going to be, typically going to have white smoke with these things, paper, wood, cardboard, plastics. Class A, the color of the is going to be silver. The symbol of it's going to be a green triangle. The silver color will be the color of the fire extinguisher itself. A Class B fire is going to be combustible liquids, oil, paint, alcohol, some gases. It's going to be a red square. It's going to be black smoke. The color of the extinguisher is going to be red, and the symbol would be a red square. Class C is an electrical fire. It's going to be, the fire extinguisher is going to be red. The symbol would be a blue circle, and the pictograms are over here. It's used to put out electrical fires because we don't want to induce corrosion into the wires. The real way you put out the Class C fires is to turn the power off so that the arcing and the sparking stops, and then the fire extinguisher is used to put the fire out that's in the insulation. We have Class D fires, which are going to be metal fires, combustible metal fires. The color of the extinguisher is yellow, and the symbol's a yellow star, and a good agent for that, or at least what I was always taught, a good agent for that's going to be sand. A Class K fire are flammable materials like cooking oils and fats. Again, the color of the extinguisher is going to be red, and it's going to be a black hexagon as the symbol on the red extinguisher. So we did the physical security. Planning, or site security. Planning is one of the things that you need to do in site security. How are you going to protect it? How are you going to control it? Not always the easiest thing in the world. One place that I visited one time, they kind of just signed you in, but when you got out, they had a really extensive search. It was a home shopping network warehouse, and they were showing us the new system that they were installing, but they were really picky, as you might expect, getting out of the building. So the review is describe the use of physical security and environmental controls in planning and implementing site security. Identify the key features of environmental and fire suppression systems that impact security. These are things that probably are not new concepts to you. The environmental as security, we've got to protect the equipment, and that's what it is going to do for us. So let's do the questions, and then we can have some more lab time. I didn't copy the questions yet. What is a basic principle you can follow to plan site security?
Your traffic.
Your traffic. We're going to do that with setting up zones.
Basically, right? Setting up zones, fences, walls, doors, points of entry, stuff like that.
That's it. You got it. What principles should you apply regarding furniture layout in public spaces?
Ease of access to the exit doors, safety, and in case of fire, that it's properly out of the way.
Yeah. And set up your furniture so that you can watch people.
Well, there we go.
What, I mean, you would probably do that in your house, wouldn't you?
What totally.
What use might a proximity reader be for site security? What if we put an RFID into a badge? What's it going to do for us? Sorry, Derek.
Oh,
Go ahead.
oh, the proximity reader is that thing when you scan your card or whatever?
Yep. It's going to open things for us, open doors for us as long as we're authorized to get in. And again, it probably is going to do logging too so that you know who came through what door at what time.
Accountability, yeah.
Say again?
Accountability.
Accountability, yep. And the story I told you, there actually was a guy that put in a security system, got caught by his own system because of the logging. He should have known better, but he was stealing something. I don't know what he was stealing. It was before I got there.
I'm stealing pencils.
Wow.
What three types of intruder alarm can be used in security systems?
Yeah, surveillance.
Here we go. Yeah, surveillance. What kind would you have in your house? I haven't had a burglar alarm in a long time, but
Motion.
Motion.
Well, if you have dogs, you're toast.
Yeah,
Yes,
you can actually set
circuit.
them. You can actually set them so that they don't, because if somebody's crawling on the floor, but you can set them so that they don't detect anything that low.
Yeah, my dogs are 100 pounds, so it's kind of hard to.
Oh, you have big dogs. Big dogs. What kind you got?
Got huskies.
Oh goodness. I guess that you would have in that part of the country, huh?
Yeah.
We've got setters. They're not quite that big, but we're talking 60, 70, 80 pounds. So
Oh, yeah. I had a Pyrenees. She was 120.
But anyhow, we may have motion detectors, and then circuits that kind of like our own doors, the little sensors that are wired to be sure that the circuit's
Those are
complete
cool.
when you open the door, and then duress alarms, which we have those at the banks all the time. The little buttons that they push in the movies, right? What are the main considerations to make when setting up a video surveillance system? And I didn't talk about this, so I'll answer it. Angle and depth of field. What we're talking about is how clear the picture is going to be, whether to have a static or adjustable cameras, and arrangements for monitoring and recording images. So whether you're going to have a pan and zoom camera so that you can move it, watch things, and what's the depth of field going to be, how far you're going to be able to see, and how far you're going to be able, do you want to focus the cameras. The other thing is, I really think, is where you're going to put the cameras themselves. What three elements should be in place to reduce the risk of fire?
Your escape plan, your route, and your drill.
All the above, exactly.
GQs.
What security controls might be used to implement protected distribution of cabling? If we put it in steel conduit, alarms to detect attempts to interfere with the conduit, but putting it in conduit is going to help make it secure. Where would you expect to find hot and cold aisles, and what is their purpose?
Oh, in your mainframes.
Yep. And the purpose is so that you don't blow hot air into the intake of the other guy.
Right.
What physical security device would you use to ensure the safety of an on-site backup tapes?
The cloud.
Yeah. Well, or a fireproof safe, which actually may or may not be fireproof, but I think cloud's a much better way to do that. I agree with you. What physical site security controls can act as a deterrent?
You have fencing, you have dogs, you have security walking around.
Mm-hmm. All of those.
Yep. My buddy was building a house. He put a fake camera up, and it helped.
Yeah, I mean, yeah, when you put a sign up, say that it's under surveillance, those kinds of things.
Yeah.
So that people wonder. We have a bunch of cameras in the building, where I taught before, and most of them work, but some of them they had never gotten the wire to, but nobody except the networkers knew which ones were live. What really was interesting is they put one in somebody's office, and boy, did they panic. It was not a live one. Anyhow, are there questions?
Negative.